All right. What we're going to look at is what's in that glass. Have a look at it. Now, what do you know about air and oxygen?
Oxygen.
Oxygen help you breathe.
Yes?
And air is something you cannot destroy. You can't make air.
Look, I'm making air. Actually, I'm not because I'm sucking air in and blowing it away.
There you go, yeah. You're just moving it around.
Fans kind of make air.
They don't
act this way.
They move it all around. We're going to investigate air today. Your first question is about weight. Now, which of those two things is heavier?
That one.
Experiment? Why is it heavier? Show me why.
I'm going to make them both fall at once and see which one is heaviest.
Excellent experiment.
I'll try that. 3, 2, 1.
So which is heavier?
This one.
Lucas, what's that in front of you? What's this white thing?
That's
Yeah.
a balance.
A balance, that's right. And it tells you about what?
It tells you about the weight of things.
Okay, so if something's heavier, what happens to the balance?
It goes down.
Okay, so what do we have on the balance right now?
We have a blue not blowed up and a blue blowed up.
So what's your scientific prediction? When Lucas and I let go of these things, which end's going to go down?
The right hand, the left hand.
This one, the one I'm holding?
Yeah.
All right, okay, Lucas. On the count of 3, let go and see which one goes down. Ready?
2, 1, go.
No, you were right that the heavier one goes down. What this shows is that the big balloon is heavier. Okay, so they both have the balloon skin, but what's the difference between them? What does one have that the other one doesn't have? They both have balloon skin, but only one's got air. So why is the big one heavier? So what that shows is that air weighs something, just like everything.
That's it. Of course.
Now, there's lots and lots of air. There's about 3 miles of air right on top of you, and all that air is pushing down upon you. In fact, right now, there's air pushing down upon you that's the same weight as a car.
So
I can't feel it.
squished
No, you
by a
can't.
car.
Can you see this?
Yeah.
There you go. Okay, so I'm putting a card on top of there, a little snap card. Then, I'm going to turn this upside down. Okay. So what's inside here?
Water.
And air.
And air, that's right. And look what I do over here. What's going to happen when I let go? Can you guess it?
He's gonna pull it on his head.
You ready?
Yeah.
Give me a, Charlie, you give me a count.
3, 2, 1.
Oh! That was not supposed to happen.
Should I stop now?
All right, let's try that again.
Should I stop?
No. Okay, you ready?
Yeah.
Now you ready, Sam?
No.
You ready? 1, 2, 3. Whoa! All right, so the first one didn't work so well, and Sam's a bit soggy. Blow that balloon with all your might. All right, so you sort of got it to move. What do you think's going to happen if you blow between these two balloons?
They're gonna separate.
Good guess. Let's give it a go. Did they separate?
A bit. No, they're coming together.
Watch. They go towards each other.
I'll do it.
Why do you think they went together when you blew? What happens when you blow?
It wants to stay down, but it goes up for a second,
It goes
and then
up.
goes on wobbly because it doesn't know where because it doesn't know if it's meant to go or not meant to go.
But why would it go up?
If you did that with a piece of lead, it wouldn't move,
No,
and you'd never be able to hold it.
it would if you did it fast enough. In fact, this is why a plane wing goes up, and that's made of metal. All right, let's figure out what's going on,
Oh,
and
we're
we're going to use army men. Can't see air molecules because they're very, very small. So instead we've got these army men. What they do as they move around is they bump into this bit of paper. And we've got air molecules this side. How many air molecules are that side?
5.
And how many are that side?
5.
So is this bit of paper going to be pushed this way or this way?
Because it equals amount of soldiers.
Is when you blow and you move these soldiers, they move really fast and they thin out, right? So if there's only 4 soldiers there, and 10 soldiers there, which way is the paper going to move?
That way.
That's right, because all these extra soldiers are going to push it.
Hey!
Look at these balloons and imagine that there are soldiers all the way around them, surrounding them, bumping into the balloons and push them all around. But when you blow in between them, you reduce the number of soldiers, you thin them out between the balloons. So what happens?
They'll be together.
They'll go together. Exactly. When we heat up these soldiers, they get more energy and they start to run around more. And they start to expand.
Ow!
They get more and more energy and some of them leave. So these guys did have more energy, but then they cool down. Now what's going to happen that they're cooled down?
They're going to go this way.
Exactly. We have a plate here that's quite heavy and it's got a wet rag on it. And we have a glass. And this is what we're going to do.
We're gonna sit on the night.
Okay, so there it is, a light, right?
Do you think it's raining?
Sounds like it, doesn't it?
Or there might be a mini flood.
It's steam. And it's
Oh,
cooling.
there it is, there it is, there it is! Why is the plate hovering?
Because the air is holding it.
How's the air holding it?
Because the fire, it makes the...
Charlie,
Smoke goes up.
Yeah.
So does the plate. Because it's got smoke on it, so it'll go up.
How do you explain the water?
We had air molecules outside the glass, soldiers here, and we had air molecules inside the glass. Now what do we do to the glass? What do we put inside it?
I don't know. A piece of paper.
And what was the piece of paper doing?
It was a light.
That's right, so these guys got more and more energy, but that made them leave the glass. So now there's only one guy inside the glass, and lots of soldiers outside. So what do those guys on the outside do?
Try to...
They push, exactly, they push. They push the plate, so you've got lots and lots of soldiers pushing up, but only one guy in the middle pushing out. So the plate gets pushed onto the glass by all of the air pressure. Okay, so we're lighting the candles.
Is the egg still having a
No,
spoon?
no, it's the bottle.
Oh look what happened to the bottle, oh, squashing.
No!
Oh no! It's being squishilated.
The bottle squashed. Why did the bottle squash like that?
Because of the air?
No, because the outside air molecules are pushing.
Exactly, and what happened to the air molecules on the inside?
They're not very much, so they can't really push out.
That's right, they all fled because we heated them up. So they had too much energy and they fled. Exactly, why was...
Exactly.
Exactly. So Charlie's going to line them. That's one.
I hope this works.
2, 3. Okay, Lucas. Get the bottle, turn it upside down. Hold it above and let's try and get those lights in. There we go.
Oh look, two were stuck together. That's so cool. Oh, it's still going.
Oh! It went inside, look at that!
It's like, oh,
It shredded
now,
the egg, but it got
now we
inside.
have a new science.
Yes.
Egg science. We are looking inside its heart.
Bleh.
That is awesome.